Alright, welcome. Today we got a very important part we're going to introduce to you. It's called a potentiometer. And let me show you what it looks like. It comes in a variety. Here's one. Let me switch to maybe a view that might clean things up just a little bit. Here is a potentiometer that you do not have in your kit. I just want to show you the different designs. Notice we have 3 wires coming out, a big knob coming out, which usually you attach a knob to it, a nice pretty little knob, and this thing turns like that. I have another one. I don't think you have one of these in your kit, so I'm not going to use it, but these are pretty common. They're smaller. They have 3 little pins coming out the back, just like the other one. And it doesn't look much like a knob on this side, but you actually turn it left and right. I've got those. The one in your kit, I think, will look just like this. I get to focus there, maybe. No, likes my face. Let me do this. See if we can get to focus. Ignore my face. That's a little better. Okay, so it looks like that. Now, yours probably comes in 2 pieces. So let me tear this one apart. You have the knob and this little base, again with these 3 little legs coming out. On the top, mine says 10K. So, we'll try this one more time. Make sure you get the right part. Looks like that. On that side, it says 10K. Alright, and there's a little hole, a little yellow, a little white spot in the middle. That's actually a little hole there. And then you'll take this knob, and if it's not already in there, you'll push it in like that, and then you can turn it just like the other 3. So regardless of what it looks like, they have 3 wires coming out of them, and I'm all blurry. What's going on? Unhappy. I'll shrink myself down so we don't care if I'm blurry or not. So it's got 3 wires coming out of it, and some little knob that we turn to change things, and that's the important part. In the previous build, we had you take user input that they typed in on a keyboard, and you introduce that into your program. And that's useful. This time around, we're going to do something very similar, but the input from the user is going to be turning this little knob. And a potentiometer works just like a resistor. We found in class that we need resistors once in a while because they keep our parts from getting damaged. They'll absorb some of the voltage and protect our LEDs. And the potentiometer acts just like a resistor, except we can change its value. We can increase it or decrease it. And I'll show you why this is such an important part. Let's go to our build first. Alright, it's going to be stubborn. There we go. Let's move this. I don't want a wire. I want to move this over to there. And in our list, our potentiometer even looks different from the 3 I showed you, other than the fact that it's got the 3 wires coming out and a little knob. This is looking straight down. Now the knob, the turning of the knob is a little weird. If I start the simulation, I think it'll hopefully do this. I can grab it and turn it around like that. Alright, so we're going to take this and put it into our breadboard. That looks like a good spot. Now one of the wires, we have basically two end wires on each side, and then we got a wire in the middle. The wire in the middle is going to be the important one. It's going to be our signal wire where we're going to be taking our information from the potentiometer. So let's start with that one. And let's use a pin we probably haven't used before, these analog pins way over here, A0 through A5. So let's draw a wire, and let's pick on A5 today. Let's change its color to yellow. I like my signal wires to be yellow, I don't know why. And then these two wires, it doesn't actually matter which one we pick because it's a symmetrical part. We need to send one to ground, of course, and the other one needs to go to a voltage source. So let's pick this one on this side and send it to ground. And I'm going to switch its color to black. That's a color we use to represent ground. And this one, we're going to swing it all the way over here to 5 volts. And we're going to change it to red. Alright, that looks pretty good. So it's a fairly simple build. Give me just a moment here and I will show you what that looks like without the software. Alright. Mine is actually slightly, the one I'm going to pick up and show you what I did that's slightly different is I put my wire way over here to this ground, but that crosses some things. We can choose that ground if you want, or we can choose this ground. So that's what mine looks like that I'm going to show you. They're all on the same rail over here. And I'm going to switch, we'll risk going back to the camera only. It just does not want to focus on me anymore. Oh, there we go. Now it found me. I don't want to find me, I wanted to find this. So here's a view of what mine looks like. Compare it with yours. This little tilt. I got a big long yellow signal wire. And then you can see where I've plugged them in on my Arduino. Red 5 volts, black was the ground. The yellow one I sent to A5. Alright, hopefully that's good enough. What also makes it slightly different with what you'll have and how it varies with this picture, let me swing back to it. On this Tinkercad, the signal wire is on the same side as the ground, which I wanted to go back to it being black. So there's my ground and there's my 5 volts. On the build you're going to do, since we have, pull this back out again, one of our wires is 2 are in front and 1 is in the back, so it's slightly different than what you're seeing in this view. This one, all 3 wires are in front, but for the actual build, this one is pointed into the back, so that's slightly different. Just want to point that out. Alright, build mine, fix it up there a little bit, get it rolling again. Okay, that looks good. Let's go and write some code. So the goal this time is to have the user turn that knob, and we're going to get information from the user. Now it's not some number they're typing in, it's not a message they're typing in, it's the value on that potentiometer. That's what we're trying to input. And we're going to use that value to do something else. What we have to do is it's unlimited. We could use it to control an RC helicopter, or we could use it to turn the lights on or dim the lights, or we can use that to operate any of the other gadgets that we toy around with. So let's give ourselves a little space, clean it up a little bit, take these comments out, That looks good. And we're going to display the values we get from our potentiometer on the serial monitor. So let's set that up like normal. I think all the code you'll see this time around is something you've seen before, except for one line. Since we're using the analog pins, we're going to need a brand new line of code to show you how we take information from an analog pin. Up to this point, we've been using the digital pins, and we've been using digital write, digital read, analog write, and now we're going to do analog read this time. So let's finish this part up. We'll show you how that works. And now we've got the serial monitor working. And let's jump down here. We need to assign a value. We're going to be collecting information from the user by turning that knob. So we need to be able to collect that as a variable. And it's going to be an integer. So let's go back to the top. And let's call it it's potentiometer. So we'll use the first three letters of that. POT will stand for our potentiometer. And let's call it pot pin. We're not going to give it a value. We're not going to call it something like we would normally do. Say it's 12. We're just going to say, hey, there's this variable you don't recognize. We're going to call it pot pin, and it's an integer. That's all you need to know for right now. So the computer will relax and not throw those fits. So we're going to use that pot pin, and we're going to collect some information from pin A5. So to do that, we're going to use a new line of code, analog read, and mine is, double check this, is on A5. A5. Whoop. If we wanted to, we could actually make A5 a variable, but since we're only going to use it once, I'm not going to technically, we absolutely need a variable for pot pin, but since we're only going to use A5 once, we're not going to waste the time making a variable for A5. If we were to use it and change it throughout our program, we might consider doing that. Okay, so this is going to read the value coming in from A5. And let's take a look at it. Serial print. Let's have it make a line afterwards. Whoop, we don't want parentheses. We're just going to read that value and take a look at it. And it's going to read this and then read again and display it, read again, display it, read again, display it. So let's put a little delay in, not very long, 1/10 of a second, just to slow things down a little bit. I'm now going to take my Arduino and hook it up to my computer. Plug it in. There we go. Didn't get my happy sound, but that's all right. Seeing it recognizes it. Let's double check our port. It found that one automatically. Recognized the board, so we're good there. And let's upload. A good practice would be to actually give this a name. Potentiometer, we'll call it that, and save it. There's a folder, it's saving all of these too. We can go back and look at them if you wanted to. It's good to know though, if you lose your work, you've got it saved somewhere. Alright, let's take a look. And we've got zeros. That means either we have an error or our knob is turned all the way to one side. Let's give it a little turn here. Let me show you what I'm doing, kind of in the corner, hiding. I've got my little breadboard here, and I'm taking the knob and I'm going to turn it slowly, and you see the values going up and up and up. And they stop at 1023. I can't get it to go past 1023. And then it's headed back down to 0. So by turning this knob, I can input values from 0 to 1023. And this is going to be extremely useful later on in future builds. Now you might ask, why does it stop at 1023? It's for a similar reason that we saw earlier with the analogRead, when it stopped with 255. If we add the 0 onto 1023, we get 1024. And this might be slightly confusing, but there might be a few students out here who will get this. At 256, that was 1 byte. And if we take 256 and double it, we get 512. If we double that, we get 1024. So I guess that would make this 10 bits. Doing that in my head real quick there. Give you about 90% probability of getting that right. Pulling that out of my head there. So this is nice. It's working properly. I can turn that. Now skipping a bunch of values because I have it going every 1/10 of a second, and I'm actually turning that thing relatively fast at 1/10 of a second. If I got rid of this, let's do that real quick. Upload it again. You'll see that indeed I can get any value in between there. So I'm lifting this up and I'm turning it. It's very responsive. I mean, I just barely touched that and it's moving, cycling through all those values. And the sky's the limit with what we can do with this. We can write a little program that says, all right, when this is above 800, do something. When it's below 300, do something. Or be doing something as we change the values. And we don't need anybody to type something in. We can just turn that knob. All right, there's one more thing I want to show you. And this will be it for this lesson. This is also kind of cool. When we're printing out just numbers, we can use something besides the serial monitor. Serial monitor is great for everything. However, if we just have numbers coming up, we have another option if we're using this IDE, and that is if we look under Tools and we go down to Serial Plotter, we have another option. It should be pretty obvious what it does when I open it up. So we open it up and we got like a little graph here. We got time along the bottom and we got these values that we're able to input. And it's fluctuating a little bit right now, probably because of some noise in our wires. But let's turn it and see what happens. We change our values. There's 0. Now I'm going to go back up to 1024 and back down again. It's like a Etch-a-Sketch. There's no delay, so it's just spitting out numbers really fast. Well, that's kind of cool that we can take our values and we can graph them. This is going to be quite useful. Say we make a thermometer, which we will, a digital thermometer. We can actually post our values up here and watch them change in a graphing setting instead of an LCD, which we'll also do later on. We'll display it. This gives us some more options. All right, so that's good enough for now. Seems really simple, and it is. I like that it's simple and yet very, very useful. So I will see you next time with the next build. If I get this thing to stop. I hit the wrong button. Let's try it again. I don't want to stream. I want to stop the recording.